Adam Rees on the universe and our understanding of it. Excluding the measurement errors, there remains the real and exciting possibility that we have misunderstood the universe. A Nobel Prize winner warns us. The James Webb Telescope shows us evidence that something strange is going on in the universe. If we believe the latest measurements from the James Webb Telescope, then our cosmos would have shifted in such a strange way that there is simply no explanation for it. But what would that mean in concrete terms? Are we really powerless against the latest developments, or do we perhaps already have a new explanation? Adam Rees is one of the leading cosmologists of our time. Years ago, the Nobel Prize winner presented groundbreaking work on the expansion of the universe and discovered alarming discrepancies in the measurements of the Hubble constant. These differences from earlier measurements became known as the Hubble tension. Rees, along with thousands of other scientists around the world, eagerly awaited the launch of the James Webb Telescope. The new technology would finally provide proof of the true nature of the universe. Answers to questions such as, were Rees's measurements wrong, or were the older measurements wrong, should finally bring us clarity. Of course, it was also conceivable that the Hubble tension was a previously unexplained phenomenon, but nobody wanted to face that fact at the time. The Webb telescope shocked scientists because the latest measurements confirmed the accuracy of all previous measurements, and thus a pure measurement error could be ruled out more and more. The differences in the measurements certainly do not occur because our telescopes measure incorrectly. Hubble and Webb each made two measurements, once using Cepheids as standard candles and once using Type 1a supernovae. In this context, standard candles are measurement constants that scientists use to achieve exact measurement results in the universe using the absolute brightness of these phenomena. Actually, both measurement methods should show similar results. What was measured was the expansion of the universe, or rather, the rate at which the universe is expanding and how it's accelerating or decelerating in the process. Minor measurement differences would have indicated a difference in the absolute brightness of the standard candle and would have been physically explainable. But the difference is so great that Adam Rees suspects that the Hubble tension is pointing us to other fundamental misunderstandings about the universe. Adam Rees has found the explanation. Did you know that Adam Rees is the father of dark energy? In 2011, Rees shared the Nobel Prize in Physics with Saul Perlmutter and Brian Schmidt. The three scientists were honored for their special discovery that the universe is not only expanding, but is doing so at an increasing rate. This realization also shocked the researchers, because actually the universe should be slowing down. Imagine how the Big Bang was an initial energy and then the universe races off, forming matter and taking up an ever-increasing space. According to our current physics, it should actually slow down at some point. This idea that the universe will eventually run out of steam, so to speak, led to the Big Freeze theory, in which the universe will end up in a kind of state of shock at some point in the distant future. When all energy is used up, all processes come to a halt and the universe practically freezes. But the measurements taken by Rees and his colleagues showed that the expansion of the universe is not slowing down, it's accelerating. But how can that be? This counterintuitive fact led to the introduction of the concept of dark energy. This force, which no one has yet seen or measured, is thought to be responsible for the mysterious accelerated expansion of the universe. To confirm these theories, the Hubble Space Telescope was used before the launch of the James Webb Telescope. Adam Rees works not only as a professor of astronomy at Johns Hopkins University, but also at the Space Telescope Science Institute, which is responsible for the Hubble Space Telescope. The James Webb Telescope confirms Rees's theory. Think for a moment about your view of the cosmos. Do you also imagine a space in which there are objects that rotate, turn, are created and destroyed? And can you perceive that this space is getting bigger and bigger? This is a notion that may seem a bit crazy to us, but it is a fact. The universe shows evidence on many levels of an expansion of the total space it occupies. Until now, The only logical explanation for these effects was that the universe expands from a starting point, but as already mentioned, the universe would then have to slow down at some point, or at least it should not expand faster and faster forever. This is where the James Webb Space Telescope and its unique mission come into play. In the 2 years of operation, NASA's newest telescope has already shown us many phenomena that confirm Reese's theory. These include galaxies that are so old that they shouldn't really exist. Furthermore, so far, there has been no sign of a dark age or of real relics of the Big Bang. Thanks to Webb, we can see clusters of galaxies that are so vast and so large that they challenge the theory of an isotropic universe. All this, together with the phenomenon of the Hubble tension, confirms the assumption that we simply did not understand the universe correctly so far. These new findings will now possibly lead to fundamental changes in science. It is not only Adam Rees who sees that the scientific understanding of the world and the universe is currently facing major challenges. Throughout science, more and more researchers admit that more and more unsolved puzzles in cosmology are forcing us to rethink. Radical changes in the universe confirm it. Who would have thought that a simple telescope could cause our entire cosmology to collapse? Although the James Webb Space Telescope is not just any instrument, but the best telescope we humans have ever built, nobody expected these observations. It's as if a completely different universe is suddenly appearing before the researchers' eyes than the one they thought they knew. There are indications that the universe is older than assumed, and that galaxies were formed faster and differently than previous theories had predicted. We may even have to get used to the idea that the universe is infinite. Perhaps we don't even come close to understanding how matter really comes into being. James Webb also provides observations that cast doubt on the existence of dark matter. If dark matter does not really exist, another pillar of the old theories will have been lost. But how can we then explain the phenomena that led to the invention of this mysterious matter? It was researchers like Edwin Hubble and Fritz Zwicky who predicted that there must be an invisible form of matter. Only with the help of this form of matter could the incoherent rotational behavior of galaxies and some other phenomena be explained. There are some other approaches to explaining these phenomena without the existence of dark matter, but they are not quite as coherent. Webb also shows us that the assumption that the universe looks the same in all directions could be flawed. This effect of uniformity is what scientists call isotropy. If this isotropy does not exist either, then the old cosmological model is shaken even further. In the early 2000s, Rees and other researchers introduced the concept of dark energy to explain the accelerated expansion of the universe. However, the existence of this form of energy is still unproven, just like the existence of dark matter. Due to these new discoveries, it's expected that the standard model of cosmology will soon be fundamentally revised. But where could this change lead us now? These new worldviews amaze us. Imagine we live in a cosmos in which not a single physical constant is correct. That would mean that Einstein's theory of the constant speed of light is not true, that standard candles can never produce the same results, and that physics changes regionally and even over time within our cosmos. Such considerations arose after the latest measurement results of the JWST, and the latest theories go even further. In addition to the idea that our physics can only describe a part or an epoch of the universe, there are approaches that see intelligent forces in dark matter or dark energy. This would mean that our cosmos has something like a soul or its own intelligence, which in turn could explain who created the universe in the first place and why. We would still be a long way from having real answers to our questions after such insights. But if such crazy assumptions were confirmed, we would at least know that there is such a thing as a creator intelligence. Until now, we have always looked into the light and into matter to understand the universe. But now, it is becoming apparent that the structures we are looking for prevail in the mysterious darkness of the universe, of all places. However, this has not really been proven either, and we will have to continue to observe what is unfolding before our eyes what measurement results we get from the latest Webb observations, and what that means for our science. We humans have begun to explore our surroundings and, at some point, the universe, because we wanted answers to the questions of who or what created it and why it exists. We may now be at a turning point that changes our old worldview so dramatically that it resembles a revolution in knowledge and science. Less daring theories simply state that our universe is much older, or that it may have no beginning and no end. But where do the signs of expansion come from? Here, too, there are exciting new ideas that suggest that our cosmos is subject to regional currents. You can imagine it something like a wafting bubble formation that contracts or expands regionally, reaching different rates of acceleration and expansion. If there never was a Big Bang, it makes perfect sense. It is hardly surprising that there has been no real evidence for the Big Bang either. Only the fact that, for a while, all the theories fitted together quite well seemed to confirm the idea of a starting point some 13.8 billion years ago. But we have never seen any real evidence for it. If we take another look at quantum and particle physics, we find further evidence that something is wrong with our old worldview. From the quantum world, we know that our universe must be far more changeable and flexible than previously assumed. And you may be surprised to learn that not a single piece of evidence for the real physical existence of matter has yet been found in particle physics either. Our cosmology, however, is based on the observation of material phenomena, and from the behavior of matter, researchers have drawn conclusions about forms of energy and forces. This could have been a blatant mistake. Subscribe now and look forward to many new video hits.